Hey guys, I hope it's going well. This is our last lesson actually in this unit, and it's looking at some applications. So it's kind of a departure from some of the things we had been doing, but hopefully you'll be able to bring back some of the things you already know in terms of sine and cosine law and all those things in order to apply them. I would encourage you to try this first question without watching the video and see how you do. And if you need any help, obviously you can watch the video. So this one asks for the length of KS. So let's identify that first. So there's KS. And we've got a three-dimensional triangle here, or prism, with that, it's got a bunch of information in it. Just so you're aware, this 50 degrees is the angle between, I would call it OKB, so that would be that angle. And then 60 would be KOS. So often in these questions, similar to two-dimensional problems, what you have to do is use common sides in order to figure things out. So what I'm going to do first is this should be 90. So BOS, they tell us, is 90. So that's that guy. And then BOK would be like here, like that. So it gets a bit confusing when you see this, when something's supposed to be coming out at you, like the triangle BOK coming out towards you. So what I'm going to do is I'm going to draw separately some of these triangles. So I'm going to do BOS first. So B was up here, O and S. This is 90. I'm going to label these things. 35 degrees. I think there's one O, and the height here is 10 meters. So that's that part. We can also use another one, but what I think we're going to have to do is in this triangle OKS, we're going to have to find more information. So maybe we can find OS first. So I'm going to find that. So that'll be our step one. So if I want to find OS, we can go back to using SOHCAHTOA because we've got a 90-degree triangle. So I've got the opposite side and I'm looking for the adjacent. So the tan of 35 equals the opposite over the adjacent OS. So I'm going to rearrange this. So OS equals 10 over tan 35. Like that. So we end up with OS is equal to approximately 14.3 meters. Like that. Great. So second thing, I think we can take BOK. So that's the triangle that's coming out. And I'm going to draw it just like I drew this one. So B's up here. Oh, but notice this is the triangle that's coming out at you, but I'm just going to draw it like this, flat in 2 dimensions. So again, here's my 50. And so I'm just going to highlight this just so you see it. So it's this guy here. There. And then my height's still 10, so that's a common side already. But this OK side, which will help me find more information for the KS. So I've got OK, so I'm going to find that guy. Oops. So again, I've got tan of 50 this time. I'll rearrange that. So that I end up with, punching that in, approximately 8.4 meters. Great. So now I have this triangle. So if I draw it out, so I've got OKS. Let's see if we have enough information. So I'll draw it kind of as it's drawn on the page. So that's the flat part at the bottom. So we're looking for this. We now have this side, OS. which we said is 14.3 approximately. I've got this side okay, which is 8.4 approximately, and I also know this is 60 degrees. So if you recall, I now have a side here, the side, an angle, and a side, so that this angle is contained between the two sides. So what I can use is use the cosine law, and that's going to give me Ks. So I'm kind of running out of space, so I'm going to do it down here. So Ks squared, if you remember, is equal to the other two sides squared added together. So 14.3 squared plus 8.4 squared minus 2 times the two sides multiplied together times the cosine of the angle between them, and that's the angle that's opposite the Ks. And so if you work this out, so Ks squared approximately, and you want to keep as many numbers on your calculator as you can for this part, approximately that, and then we take the square root, and I get approximately 12.4 meters. So therefore, Ks, oops, not Kc, is approximately 12.4 meters. And we're good. So again, using all the things that you know in order to find out. So if you got common sides, you can try to figure that out and use that to find the other parts. Okay, so the next couple questions, we're going to look at something we talked about briefly last unit, and that's looking at conventional and true bearing. So just to repeat how this works, conventional bearing is more like the orienteering type thing that you use in order to figure where things are. In this, we always use north or west as the primary angle, and then we rotate east or west. So for example, the primary angle or direction here is south. So I'm pointing mostly south, but then I'm rotating 60 degrees to the east. So this would be south, 60 degrees east. The next one obviously is pointing mostly north. This would be north, and then it's rotating here to the west, 30 degrees west. So hopefully remember that stuff. Then there's this other one which is called true bearing, which starts north and then goes clockwise. So like this angle here to the 30, I would have gone 90 degrees to east plus 30. So this would be called 120 degrees. No north, no south. It's just always denoted by 100 or whatever angle it is, starting from north being 0. And the next one that's rotated almost 360 degrees goes from here to here. So this one would be 270 plus 60, or 330 degrees, like that. So two different ways to express your direction. So for example, we could use it in something like this, where it says Sarah biked 10 kilometers north, 30 degrees east. She then biked 8 kilometers south, 80 degrees east. How far is she away from a starting point? So in these questions, and this kind of gets into vectors, and if you go on in calculus and vectors, you'll do this stuff. You want to make a diagram that's fairly large, and we'll just put here north, and then that implies what south, east, and west are. So the first thing we're going to do, she's going 10 kilometers north, 30 degrees east. So that means she's rotating from here to here 30 degrees. So we draw our first leg of this. So let's say that's 8. And so that takes care of that. So that's the 30 degrees, and it's 8. The next part, though, what we should do is draw what's called the compass rose again. So we just create another little grid where, again, this is north. You don't need to label it north, but so that we can change directions based on north, south, east, and west. So the next part, she says she's going, oops, I put 8. That should be 10. So this is 10. Let's put this back in. So now she goes 8 kilometers south 80 degrees east. So she's going from here. So this is where she stopped, and now she's starting again. And this time's the 8, and this is going to be from here to here is 80 degrees. And so what they're asking for is, what's the distance from where she started to where she ended? Like that. And so this is our unknown. I'm just going to say let x represent the unknown distance. So if you look at the triangle thus far, we really don't have a lot of information other than these two sides, the 10 and the 8. But what we can do is use a little pattern here. And so if you notice, I've got this line here is parallel to this line because they're both east-west. I've also got this line here. So what I've got is the Z pattern. What that implies is that this angle, if I highlight here, of 30 degrees should be the same angle that's here. So this becomes 30 degrees. So if I redraw this overall triangle, something like that, I know that this is 10, this is 8, this is the thing we're looking for. And I now know this whole angle will be 30 plus 80 or 110 degrees. So these questions often will work out in a similar pattern where you've got a side, an angle, and a side. So again, we're in a situation where we can use the cosine law. So if I set this up, using that formula, the cosine of 110 degrees, that's the angle between them, and then I can work it out. And you should end up with 14.8. So therefore, Sarah is 14.8 kilometers from our starting point. So if you were to go on in math, what they would also ask you to do is try to find out what this direction is. And so in vectors, that's kind of the next step. But let's try one more, and then you can try some practice questions after. So this one, somewhat similar, although slightly different. This says 2 ships left Port Hope, a place in Ontario, on Lake Ontario at the same time. Ship A traveled 12 kilometers an hour on a course of 235, so now we're into true bearing. Ship B traveled 15 kilometers an hour on a course of 105. How far apart were the ships after 4 hours to the nearest kilometer? Okay, so let's draw this or set it up. They're both kind of going to be down below north, so they're both generally facing south. So I'm going to draw it like that. And again, sometimes you end up redrawing these things, but so let's just start with the first one. So ship A traveled 12 kilometers an hour at 235. So let's draw in 235. So remember, this is 0 degrees up here, 90, 180, and 270. And it can be confusing because that's the opposite of what we would have seen before when we were dealing with angles in standard position. So 235 is going to be somewhere around here. So let's say here the origin is the starting point. That ship is going that direction roughly. So what we can do is we can call the ship A distance, because we need to know how far it's traveled. So what we need to do is to take the speed times time. So distance equals speed times time. So our speed here is 12 kilometers an hour, and notice it says it's going for 4 hours. So multiply it by 4, and we get 48 kilometers. So I'm going to label that 48. So the next part here is ship B traveled 15 kilometers an hour in a course of 105. So I'll do this in a different color. So 105 is going to fall somewhere there. Again, starting from the same point. So that's 105. And so we can do its distance. So we're going to have distance equal to 15 times 4. So it's slightly longer maybe. So that's 60 kilometers. This was kilometers. So what we want is the difference between them. So we don't know what that looks like. Again, we'll call it x. So let x represent the unknown distance. And so we've got a few things going on here, but we need to know what the angle is between here. So I need this angle here. So this angle can be thought of as the difference between, in this case, 235 minus the 105. So that's going to be 130 degrees. So I'm just going to redraw this. Something like that. And here's my x. So again, we end up in a situation where I've got the side angle and a side. So I can use the cosine law. And plug it all in. So the squared version is approximately 9,600. 6.5, so that the square root to the nearest kilometer is about 98. So therefore, the ships are 98 kilometers apart. Like that. Okay, there is a handout to go with this, and there's, of course, more practice questions.